Why are irreversible processes key to understanding lost work? Have you ever wondered why some energy seems to vanish into thin air during processes? Let's unravel this mystery by looking at irreversible processes and their role in lost work. Irreversible processes are those changes that cannot be undone without affecting the surroundings or increasing disorder, known as entropy. In simpler terms, when a process is irreversible, it means that energy transformations are not perfectly efficient. This leads to energy that cannot be fully converted into useful work. In thermodynamics, lost work refers to the portion of energy that is wasted, often as heat or increased disorder. This energy cannot be harnessed for mechanical work. To understand this, we need to consider the second law of thermodynamics. This law states that the entropy of an isolated system tends to increase over time. When a process is irreversible, it means that entropy increases. This indicates that some energy has been dispersed in a way that cannot be fully recovered. For example, think about heat flowing from a hot object to a cold one. This flow happens spontaneously, but not all that heat can be turned back into work because it generates entropy along the way. Let's take a car engine as a practical example. When fuel burns in the engine, it undergoes an irreversible process. The fuel molecules break down, releasing energy. However, some of that energy is lost as heat and friction within the engine. This lost energy cannot be completely transformed into mechanical work to move the car. The difference between the energy input and the useful work output is the lost work caused by these irreversible processes. Another important point is that no machine can achieve 100% efficiency. Real-world processes always involve some form of friction, turbulence, or spontaneous mixing. All these factors increase entropy and reduce the energy available for work. Understanding irreversible processes is essential for engineers and scientists. By grasping how these processes work, they can design better systems. For instance, they can work on reducing friction or managing heat transfer more effectively to minimize lost work. In summary, irreversible processes are key to understanding lost work because they illustrate how energy disperses and entropy increases. This makes some energy unavailable for useful work. Recognizing these processes helps clarify why perfect efficiency is impossible and guides improvements in energy systems.